Right. Hi, Year 12s. Did you like the ending of that last video? Anyway, we're on to the third video in chemical synthesis, the concentration considerations for rate and yield optimization. Right. So the concentration of reactants products will affect the rate and yield of a chemical reaction, and optimization of that is important to make money. So, concentration and rate. You will want to have a high concentration of reactants. Do you want to have a low concentration of products? You don't care for rate. Remember, you must treat rate and yield separately. Okay, so the concentration of products does not affect the maximization of the rate of reaction, especially the forward one. Right? So, how do you get a high concentration of reactants? You continuously feed the reactants to keep the rate of reaction high, because you recognize that normally if you were to just leave a reaction to go by itself, the forward rate of reaction slows down because you lose reactants as they turn into products. So how do you keep the forward rate of reaction high? You keep on pumping in more reactants so that there's always reactants to react. All right. The more reactant particles means collision occur more often. Remember, we need to talk about collision theory, and when we talk about collision theory, we mean talk about collisions, sufficient energy, and remember, we always have to talk about it in terms of rate and use words that reflect rate, like often, frequent, or rate. You know, the word rate. Thus, the rate of successful collisions increases, and thus the rate of reaction. So, how do we maximize rate? We have a high concentration of reactants and we continue to pump them in over time. Okay, concentration and yield. So you'll want to have a high concentration of reactants and a low concentration of products, okay, to ensure that you have a high amount of yield. Okay. Ideally, the cheaper or more easily accessible reactant is kept in excess. And there goes the bell, so you can all go home now. Ideally, you keep the cheaper and more easily accessible reactant in excess to ensure the full use of the more expensive reactant and higher yield of products. Okay, so you just have to think which one's cheaper, pump in more of that so it's in excess to keep the rate high. All right. Again, reactants are continuously fed into the system to ensure that they are high concentrations and the reaction mixture favors the forward reaction. And even better than just continuously feeding in the reactants is removing the products. If you remove the products, you decrease the rate of reverse reaction, and therefore you're just going to continue to make more and more of that product at a good rate as well with a high yield. Okay, so that's what you want to do. You want to make sure you're pumping in lots of the cheaper one. Make sure that you've got a high concentration of reactants continuously, and you want to try and remove the products if you can. Okay, so some considerations. Ideally, the reaction is maintained continuously, so which means that you keep on feeding reactants and removing products, but some reactions cannot occur in this way, and they are said to be done in batches. So you take a batch, you let it run until it's completed, and then you stop it, and then you can extract the stuff. All right. It's not ideal, but then if you do that, you generally run multiple batches at the same time, and so therefore the limiting rate is how fast you can remove the products and put in more reactants and then start it up again, and then you move on to the next one, and that continuously happens. All right, but that's going in batches. Yield is much more important in reactions with that can only be done in batches. All right, so the idea is that if you're doing it in batches, you have to really take into account the yield, because how much product is produced is how much you're taking out for each batch, and if it's going to be low, then that's going to be a bit useless. All right. In reactions that are done continuously, so remember, you're talking about batches or continuous reactions. If you're doing reactions that are done continuously, whereas you're feeding in reactants and removing products, the unreacted reactants, so the reactants that did not do anything, are still in that reaction vessel because you haven't removed them, because you're ideally only removing products. Okay, so those unreacted reactants are kept into the reaction vessel until they react, right? And so therefore they'll, like, if you continuously pump in that stuff, like, it doesn't matter that they are still there, because eventually they will be used up. Okay, so those are your considerations for concentration for rate and yield optimization. Next will be pressure. Adios.